This tutorial covers the play screen from the XNA complete game SpaceShooter series. It is a very long tutorial and the time is around 51 minutes. I apologize for the length, but I hope you enjoy it and I hope you learn something. Hey, welcome back to another tutorial from PH Studios. This is from the SpaceShooter. This is the play screen. Last tutorial we did the help screen, and we discussed how to split up a list of strings into both titles and descriptions. The titles are in one color and the descriptions are in another color. So this tutorial we're doing the play screen, but there's a few things I want to cover before we begin, and there are some changes we need to make in some of the classes. So in the input system, let's create a new property. Let's create a public bool, and let's call this pause game, capital P, capital G, and it's going to be get only, and we're going to return is new pressed key, and whatever key you want to control the pausing. So in my case, I'm going to do keys.escape, closing parentheses, semicolon, and the closing curly bracket. And that's it for that class. We can save it and close it. Now, enemy.cs, there's a problem with the r.next. When I did the play screen, I did a long tutorial, around 50 minutes, so I'm redoing it, hopefully to make it shorter. But we ran into an issue where r.next was causing problems. It's because we provide -50 here, and currently, our e.origin.y is -58. So r.next, the minimum value is -50, and the maximum value is -58. The maximum value cannot be lower than the minimum value, so it threw an error. So I thought of a way to keep it as dynamic as possible, so if we change our texture to something massive, the -50, it won't matter. If we leave it as -50 and we have a massive enemy texture, we can probably see it at the top of our screen. So we need to make it as dynamic as possible. So above e.position is equal to, let's create an integer called, what do we want to call it? Y position. Alright, so that is equal to e.origin.y. Now we want to keep it dynamic, and the origin currently holds e.origin.y holds half of our height of our texture. So it's the center of the texture's height. So if we create the giant texture, the e.origin.y will be the center of that giant texture. And we multiply it by -1 because we want it negative. We want it outside of the screen at the top. So that'll be negative. Okay, so now in e.position is equal to the new vector 2. In the second r.next, let's replace -50 with 2 times y position. So it's twice of what this is. And now let's delete the 0 minus int e.origin.y, and let's just y position here. Okay. So all this should be is r.next, opening parentheses, 2 times y position, comma, y position, closing parentheses, semicolon. Alright, so that should not be an issue anymore. There's one more thing in enemy.cs that I was going to demonstrate, and I probably still will, is this will not work. And I'll demonstrate that at the end of the tutorial as to why it will not work. Alright, so let's go ahead and build play screen. Right click the screens folder, go to add class, and call it playscreen.cs. Then make it a public class play screen, and let's make a derivative of game screen. Alright, now add these following these 3 using statements. Using Microsoft.xna.framework, semicolon, using Microsoft.xna.framework.content, semicolon, and using Microsoft.xna.framework.graphics, semicolon. the 3 using statements I've highlighted, add those to your class file as well. Alright, so now let's click the game screen, and then we get the little purple box underneath G. And let's implement abstract class, and now we're ready to go. Delete the throw new not implemented exception, because we will implement it later. And above it, let's start coding. And first, let's worry about our fields. Fields. Enter twice, and let's do end region. Alright, so it's a fields region. And what we want to do here is the play screen. So we want a list of game elements. Our player, every enemy, and every bullet that's on the screen, we want it in a single list. Now we have a list of gameplay objects. Remember, the ship is a derivative of gameplay object. Both ship and bullet are derivative of gameplay object. Both enemy and player are derivative of ships, so both enemy and player are also derivative of gameplay objects. So we can add an enemy and player in this list as well. So we have a list of gameplay objects. Let's call it game objects is equal to new list of game objects. Alright, so the game objects is going to hold a list of everything that's going on in our game. It's going to be the most up-to-date list because we will modify it as we're updating. Now, if you remember from one of my older tutorials, I might have mentioned this, that if we're doing a for each loop with a list, it's not that easy to modify that list. So we need a secondary list to hold our current game objects. So that way we can modify our main list, which is just game objects, and worry about that. So our game objects is going to be the most up-to-date. The current game objects is going to be the previous loop's object, which means the previous loop, everything's fine. In this current loop, if we want to kill an enemy, we remove it from this object, this list, and not the other list, because we're currently looping through this list, and we just want to modify a other list. It's similar to what the screen manager is doing behind the scenes. Alright, so now we need a time span. And that's how long the enemy will spawn for. So an enemy spawn timer. So it'll be a timer for when the enemy is okay to spawn. So a timer requires a seconds, or whatever you want to pass to it. It can be minutes, seconds. I'm going to be doing seconds. And you want to keep track of that seconds because you want to do the cool thing that I did is every time a enemy spawns, the seconds decreases. So an enemy will appear faster and faster. So let's do a float spawn seconds. Now that will keep on decreasing until it reaches 0. And then we want to go to the maximum we can allow. So let's have another one called max spawn seconds. So that way it's more object oriented. All we need to do is modify this max spawn seconds instead of modifying everywhere else in the code and worrying about it. So we have a spawn seconds and a max spawn seconds. Every time an enemy spawns, we'll decrease the spawn seconds and generate a new timer. And we'll get to that later. Okay, so now we need a dedicated player object. Because there's a few cases where we want to get to a player. If you looked at the source that I made a while ago, the XNA 30.0 source file, that's still on the website. Not this one we're working on now. I'm going to be doing some upgrades to this. But the old one, if we wanted to get to the player, we had to do a for each loop. And to see if we found a player, we break out of the loop. Otherwise, we need to keep on looping until we find a player. If we do it this way, we always hold on to that reference to that player. So the player reference will be both in this player object and inside the game objects and inside this. So 3 places will have a reference to our player object. But our player object will never be different. Our player will never change unless we generate a new play screen. So we do not need to worry about worrying about this single reference. So we can just set that reference and we're ready to go. So that's why we just do a dedicated player object, so we do not need to do a looping to get to the player object. It saves us some computational time. And finally, let's underneath the floats, let's add a Sprite Font. Let's just call it Font. And in the content portion, right-click Fonts, go to Add New Item. Let's go to Sprite Font, name it GameFont.SpriteFont, and set the size to 11 or 12. I'm going to set it to 12 here. Alright. So fields, we should have two lists of gameplay objects, game objects and current game objects. We should have a reference, player reference. We should have a time span object. We should have two floats at spawn seconds and the maximum spawn seconds. And we should have a sprite font, just call it whatever you want, font's fine. And that's it for the fields. Alright, so now what we need to do is we need to do the initialize, which is the constructor. So public PlayScreen, opening closing parentheses, and opening closing curly brackets. So now, spawn seconds is equal to 5. Not 51, 5. So, the initial spawn seconds for our enemy will be 5 seconds. Now, the maximum spawn seconds, which we cannot go any higher than this, let's set it to 10. You can set it higher or lower if you want a more challenging type of game. Now, enemy spawn timer, we need to generate a spawn timer, is equal to time span dot from seconds. Now, we pass it a value, so spawn seconds. So that would be the timer. We do the time span because there's a simple function in the time span, which is the time span dot subtract, and we can use the game time here to do things. Okay, so underneath the draw, let's make a new region, and let's call it static and end region. Now this will hold some static things that we want to access in like player.cs or enemy.cs or pause screen or some other screen system. We can access this. So the two things we want to do statically are make sure we are set to game over if we either died or have won, if you want to do winning capabilities. So you can have it set for that. So we need a game over boolean, and we want the ability to add elements to the class or to the list that we have inside this class without getting a reference to PlayScreen and all that junk. We can just do it statically. And the way we do that is we have another list of gameplay objects, and that's a static list, and we just call that added objects or something like that. So let's start with the boolean. So public static boolean, B-O-O-L, and game over, capital O, is equal to false. Okay. Now let's generate a static, not public, but a private static. Private's assumed here. List gameplay object, added objects, capital O, is equal to new list of gameplay object. Alright, so that's private because we do not want to edit it directly. So if we do that, we still need a way to add it. So let's create a public void add game play object, and let's call it new game object.